How does the BMS system burn out the discharge MOS? When a MOS tube burns out, you may think of the current carrying capacity or parallel connection problem. However, even if you replace it with a larger MOS tube, it will still burn out. When overcurrent protection is in effect, the MOS tube is not burned. When the current value exceeds the preset current protection threshold, the BMS is still counting down normally. During the delay, the MOS tube starts to smoke. In other words, it burned up when the MOS tube was turned off. This is related to the 4 stages of MOS tube shutdown. In the first stage, VDs is close to 0. Although the current ID is large, the power is almost 0. We can see that the VG's voltage drops, but it has not reached VTH, which is the turn-on voltage of the MOS tube, so it cannot be turned off. In the second stage, VG's has made the MOS tube work in the amplification area. At this time, the VD's voltage begins to rise, and VD's supplies power to the gate G through the parasitic capacitance CGD of the MOS tube. VG's maintains a steady state, which is the Miller platform. At this time, the MOS tube leakage current ID remains unchanged, and the power consumption is VD's multiplied by ID, which gradually increases with the increase of VDS. VD's has risen to VIN and tends to be stable. VG's begins to gradually decrease. The internal resistance of the MOS tube begins to gradually increase, and the ID current gradually decreases. Until VG's decreases below VCA, the MOS tube is completely turned off, and ID is reduced to 0. The thermal power consumption also gradually decreases to 0. Finally, the MOS tube is about to be turned off. The charge in CG's is completely released, and VG's is reduced to 0. However, although VD's is very large at this stage, ID has been completely turned off to 0, so there is no thermal power consumption. It can be seen that the maximum peak power is at T2 when the switch is turned off, but the entire heat accumulation period is from T1 to T3. When we choose MOS tubes, we often ignore the peak power of MOS tubes, which leads to the frequent smoking of MOS tubes when testing overcurrent protection. Therefore, when we want to reduce the probability of MOS tube damage, we can choose a MOS tube with a higher current margin or speed up the shutdown speed of the MOS tube. If you have any questions about MOSFET product technical solutions, you can leave a message in the comment area. I will give you the answer here. VBsemi-MOSFET manufacturer, focusing on MOSFET R&D and manufacturing for 20 years.